Okay. Right, can everyone see this?
Yes,
Hello.
sir.
Yes, sir.
Yes.
Ebo.
So which
Yes,
2.1
sir.
on which page?
Can sir tilt it, please? Make it landscape.
I
It's in horizontal now.
I can't tilt it, but I'll take a screenshot, then rotate it. Just tell me the page.
It's 1.2.
Okay, so
The
there's
next.
if you look at this one, see there's page 3, there's page 4, there's page 1 and page 2.
It's by resultant velocity. Let me just get it.
Okay.
Yeah, yes, yeah, here's it, I think. 2.1, sorry, here's it, sir.
On
2.1.
on page 2.
Yes,
All
yes,
right.
sir. Page 1, sorry, page 1.
Page 1.
2.1.
Page
2.1,
1,
yes.
2.1. A plane takes
Yes, sir.
off at Wonderboom Air Base. That's
Yes,
what.
sir. That's correct.
Okay. Did you get the resultant, the magnitude of the resultant?
Yes, I did so.
Or so it's the direction that you didn't get.
Yes, I can't see this question now. Please, I can't see it.
Rangipo. All right. Let's see.
So, sir, I got the answer here for the resultant velocity is 359, 161 kilometer per hour, and I
Yes.
got 335, 776 kilometer per hour north.
Hmm?
That's what I got.
How did you get two resultants? There's only one resultant. So the first
Oh,
one you got
sorry, sorry,
4.
sorry. Now I got sorry. Now I got 359, 161 kilometer per hour. That was my um VY that I got.
Magnitude.
Sorry, I said maybe the wrong one.
Okay.
So I got 359.
Come on,
Oh,
161.
yes. But then my direction,
What did you get for your direction?
I got west 69,21 north.
Yeah, that's the correct one.
Is that correct? So the answer here on the question paper is wrong.
Yes, this is wrong. But we'll do it. Let us do it
Oh,
together. Nah?
okay, sir. But I think I thought I got it wrong because I got everything right, but the
Nah,
direction.
you got it right. So
Okay, sir.
this direction is wrong for this question in particular.
Okay, okay, sir.
So the north 15,444 degrees west is wrong for this question.
Yes.
If I remember correctly, it's something close to what you got, but let's do it.
Okay, sir.
Right. Um, just hold for a sec. All right. There was a lot of background noise. Everyone can still see my shared screen.
Sir. Yes, sir.
Yes,
Was
sir.
that a yes or was that a yes or no? Okay. Right. Let's look at the question. Right. A plane takes off from Wonderboom Air Base in a direction north 40 degrees west at a speed of 360 degrees kilometers per hour. It is then blown, of course, by a wind of 120 kilometers per hour from a direction west 30 degrees south. Right. Determine the resultant. Right. Now, with just to be clear, I'm hoping people at this point have already watched the videos. Um, um, the person who asked this question, what's your name? Or what's your name?
Faika, sir.
Fiker. Bloody well done. Uh, it actually shows that you put in the work. The fact that you were able to get um, the magnitude of VR shows that you put in the work, you've watched the videos, and you've understood them. All right, so
Yes.
well done for that. Nah.
Thank you, sir.
Right, but let's start here with resulting velocity. Right, just like in relative velocity, you have to identify certain velocities. With relative velocity, we had to identify. You first have to identify which of the objects you are going to take as the object, and which one you are going to take as the um, frame of reference. Right, you start there, and then once you've identified those, then you follow the other steps. Right, now with resulting velocity, you have to do the same thing. There's certain velocities that we need to identify, right? And there's three velocities that you need to identify, right? One is VO, right? One is VO. Now, VO is known as the original velocity, right? Now, depending on which kind of scenario you are looking at, right? Because there's two scenarios that we are going to be looking at under resulting velocity. One where they talk of an aircraft, that's the one scenario. Another scenario is one where they talk of a boat or a ship, right? Now, for a scenario where they talk of an aircraft, right? For an aircraft, VO would be that velocity they call as the airspeed or velocity of the aircraft relative to the air, right? That would be VO. And then for the boat scenario, VO would be the one that will either be that will be the velocity of the boat relative to the water, right? So that's the one velocity that we get. Second velocity is one of, again, this depends on the kind of scenario you are looking at, right? This one we call VW, right? VW for an aircraft scenario is the velocity of the wind, right? And for a boat scenario, VW will be the velocity of the water, right? And then the third and final velocity would be VR, which is the resultant velocity, also known as the velocity of, again, depending on if you're looking at an aircraft or boat. So if you're looking at a boat scenario, this would be the velocity of the boat relative to the ground. If you're looking at an aircraft scenario, it would be the velocity of the aircraft relative to the ground, right? So with resultant velocity, you have to identify these three velocities: VO, VW, as well as VR. Right. So in this case, we have. So they said an airplane takes off from Wonderboom Air Base in a direction north, 40 degrees west, at a speed of 360 kilometers per hour. All right. So that will be your VO. All right. That will be your VO. So we have VO. Let's make this orange. So we have VO in both magnitude and direction. So this is 360 kilometers per hour. That's the magnitude. Direction is north, 40, 40 degrees west, right? Now for resulting velocity, I prefer using the vector diagram, right? If you prefer using the method of components, then of course you would have to express this such that you would have to express the direction such that it is referenced from the x-axis, right? So instead of north 40 degrees west, you would have instead west 50 degrees north, right? But seeing that for this case in particular, we are going to use the vector diagram. I'm going to leave the direction exactly it is as it is. Right? So for the vector diagram, it doesn't matter um, where your angle is referenced from. Are we clear? Talk to me, people.
Yes, sir.
Right. So we have VO. It is then blown, of course, by a wind of 120. So we have VW. VW is 120 kilometers per hour. Right. Then we have the direction as well. So that's the magnitude, and the direction is from a direction west, 30 degrees south. Now, I believe in my videos I do mention that the wind can be given in one of three directions, right? Or the direction of the wind can be given in one of three ways. One is they could either give you the wind direction from the perspective of where it is coming from, or they can give you the direction. They can give you the direction from the perspective of where the wind is headed, right? Or they the wind direction can be unclear or ambiguous, right? So there's three ways in which the wind direction can be given. One, when the wind direction has been given from the perspective of where it is coming from, right? Because on a Cartesian plane, we must always represent the wind in a direction of where it is headed, right? On the Cartesian plane, we must always draw the wind vector in a direction that it is headed. So we must always represent it on the Cartesian plane from the perspective of where it is headed, right? So there's your Cartesian plane, right? So whenever representing the wind on the Cartesian plane, you always draw it in a direction of where it is headed, which means when the wind direction is given from the perspective of where the wind is coming from, you must use the direction that is essentially opposite to what you are given. Because if they say the wind is coming from west 30 degrees south, right? So west 30 degrees south is in this quadrant. If the wind is coming from here, it means it is headed in that direction, right? So if this is the wind, if the wind is coming from here, meaning it is headed in that direction, that means this wind vector is actually going in this direction. Do you see what I'm saying here? Hello?
Yes, sir. In your video, this part where you explained that helped me a lot. I first did it where I didn't change the wind direction, and when I changed the quadrant, um, then
You
what you
got it
explained
correctly.
now got
Yeah.
me the correct answer basically.
Yes.
If you go through your video where you say like
Yeah.
the wind goes in the, say if I'm in now in west south, then my wind needs to go into northeast in the quadrant
The first.
opposite what is
Yes.
given to me.
Yes. That is 100%. Right. The reason for that is because whenever, if you think of vectors, we never draw vectors, right, from this perspective, right? The direction of our vectors must always point away from the center of the Cartesian plane. Make sense?
Yes, sir.
Right. So that is to say, when the wind direction is given from the perspective of where it is coming from, on the Cartesian plane, you draw it in the direction that is opposite what you are given. And then when they say that the wind is blowing in that direction, that means the wind is headed in that direction. So you use exactly the direction of the wind that you are given, right? And then when they haven't specified if the wind is coming from or going in that direction, you take it as if it is coming from that direction, meaning that you would have to then draw the wind vector in a direction that is opposite to what you are given. But all of this is covered in my videos, right? So seeing that this is coming from west 30 degrees south, it means it is headed east 30 degrees north, right? And then of course VR. So in this case, we do not have VR, meaning it is likely that they are going to ask us to calculate VR. Right. Now, if you look at the question, determine the resultant velocity with this direction. Right. So they, in this case, they want us to calculate VR. Right. They want us to calculate VR. Right. So we have VO going north. Show this here. What's going on here? Right. We have VO going northwest. So it is in the second quadrant. Right, 40 degrees. 40 degrees, say somewhere here. Right, right. This is it in that direction. Making an angle of 40 degrees. Right. So if this is 40 degrees, that means this here is 50 degrees, which means I'm wrong here. Which means I'm wrong. This is supposed to be more on this side. Right. And then if this is 40 degrees, it means this is 50 degrees. This is what you have. Make sure your mics are off. Only turn on your mic if you need to say something or need to ask something. Right. So that's VO. Right. Now with the vector diagram, right, it doesn't matter which velocity you begin with between VO and VW. If you like, you can start drawing VW or you can start drawing VO. Right. It doesn't really matter. You are going to get the same thing. Right. So you have VO. VO is 360. Now, if you look at VW, VW is 120 kilometers per hour, which is relatively smaller, way smaller than VO, right? Which means seeing that VW is in this quadrant, meaning it is headed in that direction, right? It means VO is going to be there, right? That's VO going in that direction. If we were using the method of components, we would have drawn it there. But seeing that we're using the vector diagram, I have it there. Right, so this is VO. Okay, that doesn't matter, just write 120 kilometers per hour. And then for this one, that is 360 kilometers per hour. Yes. Right, that is that vector. Right. Now, the two vectors. So when I said it doesn't matter which vector you begin with, you can start drawing VW or you can start drawing VO. What matters is that the two main vectors, being VO and VW, they must follow a head to tail direction. Right? You always must make certain that VO and VW follow a head to tail direction. So that is to say, had you started drawing VW first, so had you drawn this first, that is what you would have, right? And then drawing this second, this is what you would have, right? Either way, that's VO, I mean, that's VW and that's VO following a head to tail direction, right? Hence, I said it doesn't matter which one you begin drawing first, right? As long as the two main vectors, being VO and VW, follow a head to tail direction, right? You will get the correct vector diagram, right? Now we know that this angle is 40 degrees. Once you have your two main vectors, then we know to finish the vector diagram, right? You have a vector that represents the resultant, right? Now, the resultant, if you look at the direction of the direction of the resultant always goes in a direction that opposes head to tail direction or that opposes a head to tail direction, right? If you have both the main vectors, then to get your resultant, you just connect the two vectors with this line, and that line will represent the resultant. And how you show that it is the resultant is by drawing its direction that goes in a direction that follows or that opposes a head to tail direction. So these two, the two main vectors, they follow a head to tail direction, and then the resultant goes in a direction that opposes head to tail. Are we clear?
Yes, sir.
All right.
Yes.
Now remember, that this angle is 40 degrees and that's 50 degrees, right? Now with the vector diagram, right, remember with the method of components, we apply conditions of equilibrium. With the vector diagram, right, with the vector diagram, what we do instead is we either use the cosine rule or the sine rule, right? Now, as far as the cosine rule, we use the cosine rule if the angle that we have on our vector diagram is such that it is an included angle, right? Now, what is an included angle? An included angle is the angle that is between two known vectors, right? So if the angle you have is between two known vectors, then that angle you consider as an included angle, and as such, you are able to use the cosine rule, right? Now, if the angle you have is not an included angle, so meaning if the angle you have is not between two known vectors, then you make use of the sine rule. So let us work out our angles. Right, now we know that I want to draw a small Cartesian plane here. Right, so you have that small Cartesian plane, right, at this point. It's too small. Right, a small Cartesian plane. Right, remember that this angle here, right, is the same as this one. Seeing that this angle is referenced from the x-axis, it means this angle is 30 degrees. So if that's 30 degrees, it means to get this entire angle, we need to get this angle here, right? Now, if you look closely here, we have somewhat of a Z pattern, right? Do we see that here? We have somewhat of a Z pattern here, right? And because this line is parallel with this one, it means these angles are alternating angles, and alternating angles are equal, meaning that's 50 degrees, right? So if that's 50, it means this whole angle is equal to 80 degrees, meaning that here we have 80 degrees, right? So that's the angle we have. That's the angle we're going to be working with. So now we analyze if our angle is an included angle. For it to be an included angle, it would have to be between two known vectors, right? So here's our angle. It is between these two vectors, and both vectors are known, meaning the 80 degrees is an included angle. Hence, we're able to use the cosine rule, right? Using the cosine rule, right, you then name your vector diagram. Call this A, call that B, call that C, right? Then we name our sides, right? So that will be side A, side C, side B, right? We are looking for side A here. So A squared using the sine rule is equal to B squared plus C squared minus 2 BC times cos angle A, right? So A squared is equal to, what is B squared? B is 360. So that's going to be 360 squared plus C, which is 120. 120 squared minus 2 into B, which is 360, times C, which is 120, times cos A. A is 80 degrees. So 80 degrees. And that gives us A squared. Now let's see what A squared is equal to. So we have 360 squared plus 120 squared minus 2 into 360 into 120 cos 80. So I am getting here, so A squared is equal to, remember we're going to use the square root here to get the value of A. All right, so A squared is 128 996,7974. And then, of course, to get A, you would have to get the square root of this. And A will be equal to the square root of this is 359,161 kilometers per hour. Now, A here is equivalent to our resultant, therefore meaning VR, our resultant, is equal to 359,161 kilometers per hour. Right. Now, to get the direction of VR, right, you look at where your you look at the direction of your resultant. Now, how our resultant is directed, right, means that it is in the second quadrant. Right. If it is in the second quadrant, it means our angle. If we reference our angle from the y-axis, it would mean we need to calculate this angle, right? If you want to um, reference our angle from the x-axis, then it will mean we would need to calculate that angle, right? Either way, we would need to calculate this angle, right? Because here's our vector diagram, right? And the only angles we can calculate are the angles that are within our vector diagram, right? So to be able to calculate the angle either reference from the x or y axis, we first need to calculate this angle, right? So to calculate this angle, we would then use the sine rule, right? We are essentially looking for sine. We're looking for the angle C, right? So we're going to use side C. So here you would then have sine C, which is the angle we're looking for, divided by C. The angle we have is angle A, so this will be sine A divided by side A, right? So we have sine C, which is what you're looking for, divided by side C. Side C is equal to 120. So this will be 120 is equal to sine A, right? A is 80 degrees. So that's 80 divided by side A, which we've just calculated, and it's 359,161, right? Now, you make sine C the subject of the formula by multiplying both sides by 120. Hence, you will get sine C is equal to, so this becomes 120 sine 80 divided by 359,161. Then to get angle C will be equal to arcsine of this. All right. Remember, there's a comma here. Now we are going to punch this in our calculators and see what we get. So angle C is arcsine 120 sine 80 divided by 359,161. Right? And I get here, so angle C is equal to 19,210, so 21 degrees. Right? That's angle C. Now remember that angle, right, is this angle here. Right? Now say we want to reference our angle from the angle of the resultant, we want to reference it from the x-axis, from the y-axis, sorry. Right, you want to reference our angle from here. So that's the angle we're looking for. Right, it means now seeing that we've calculated this angle. Right, remember that angle from here to there is 40 degrees. Right, remember we were given that angle, north 45, north 40 west. Right, So it means to get this small angle here, reference from the y-axis, we would then have to say 40 degrees minus the angle we've just calculated, and it should give us the angle or the direction of the resultant reference from the y-axis. Right? Let's call that theta. Let's say we're looking for the theta. Right? Say we're looking for theta reference from the y-axis. So then would mean that theta, or our angle reference from the y-axis, would be equal to the 40 degrees minus c. So that will be 40 degrees minus what we just got, 19,21, which is equal to, so 40 minus this, which is 20,7. What is it? 79. Yes. So 79 degrees. Right? And then this angle is reference from the y-axis. The y-axis are north and the x-axis are west. So it would mean that the direction of VR, right? Therefore, we'd say VR is equal to the magnitude of VR is 359,161 kilometers per hour. And our angle reference from the y-axis would be north 20,79 degrees west. Right now, if you reference your angle from the x-axis, right, so meaning you want to get theta reference from the x-axis, right, it would then mean seeing that the angle from here to there is 50 degrees. To get this whole angle, you then say 50 plus this angle that we calculated, c. Right? So theta from the x-axis is 50 plus c, which is 50 plus the 19,21, which is, so the 50 plus 19,21, which is the 69,21 degrees. Therefore, meaning if you referenced your angle from the x-axis, then the direction of VR will be kilometers per hour, will be west 69,21 degrees north, which I'm thinking this is what you got, ne?
Yes, I got 69,210
Yes,
degrees.
Because you
sir.
got
That's what we
69,
got.
right. If you
Where's
got 69,
69,210? But
yes.
sir, I
Is this
didn't use this method.
What do you use?
I I used
The
the whole
parallelogram,
diagram method.
right?
Yes.
So you must have missed this when I said it, that if you preferred, you could have used this. So this is what
Oh,
you,
okay.
right? This is what you have.
Yes.
Not that.
But I attempted also um
This is what you
1.3 on page 3, and I applied the same method, but I didn't get the same answers though.
have. Okay. Okay. Before we move on, we are clear here with this one.
Yes, sir.
yes, sir, you are clear, but I also didn't use this method, but I got the same answers.
What did you use?
The method that we use,
In
Components.
your video, sir.
yeah,
Components method, yes. That's more
but yeah,
easier
components
to
method, yeah.
understand.
All right. No, that's fine. Now,
Question,
Okay.
sir.
the okay, I'll build it just now. The reason why I teach you both methods is because for resulting velocity, sometimes you are compelled to use the vector diagram. Right?
Yeah.
Sometimes they ask you to draw the vector diagram, or they straight up give you the vector diagram, and you are supposed to work from there. Right? So you should be
Okay.
comfortable with both methods, especially the vector diagram. I have found that with the vector diagram, this thing just becomes much easier. Maybe not much easier, but less serious. but you get to what you are looking for in far less steps than you would with the method of
Yes.
components. All right, someone wanted to ask a question.
Yes, sir, that's me, sir. Sorry, you have west to north, and then you have north to west. Do we need to write both angles for
No,
theta or not?
no. You just need one.
So either one.
Yeah,
Because
you
I
need one.
also used the method of components, got the same answers, while I got 69.222.
Mhm.
Which I'm assuming is right, but yeah, I just didn't get to the 20.78. So yeah.
It doesn't matter. If you, like I said, if you use the method of components, then it's likely this is what you got. Because with the method
Oh,
of
cool.
components, it's what is it? What is the word I'm looking for? It is if you're using the method of components, it's much easier to reference our angles from the x-axis, right? So
Correct, yes.
definitely, if you used the method of components, this is what you got, which is fine.
Cool. Next question. For the
Huh?
test next week, are you gonna compel us to do vector diagram? Because yeah, method of components for me is easier than the vector diagram. So just want to make sure you want to study a vector diagram one.
For the test, you won't be compelled to use any method. You could use any method.
Cool, that's sexy. Thank you.
Yeah. So for both test one and test two, but for the exam, you best make sure that you are comfortable with the vector diagram, because you don't want to get to the exam the next thing and you are only comfortable with the method of components. Next thing you get there and you are being asked to draw a vector diagram and calculate whatever quantities from the vector diagram. You see?
Got you. Got you. I'm in trouble, but got you. I need to study this method.
Yeah, you have a whole trimester to do that, because, like I said, for test one and test two, I won't be compelling you guys to use any kind of method, right? So you can use whatever method you are comfortable with.
That's sexy. Thank you.
Right. Any more questions?
So
Hi,
one
sir.
more question. I see we get 5 marks. Say for one question, is that for the answers? So we don't necessarily need to include all the steps of the calculations.
Okay, so the steps you need to include all the steps for the calculations. Now, by all the steps, I mean you need to include this, include that, or and then from here, perhaps you can write the answer.
Look at
It's
my
fine.
fucking time, bro.
But the most important steps you need to include, right? For instance, if you look
Okay,
at
sir.
when
Thank
calculating
you.
this angle, C, right? You can have this, right, and then from this step you can skip to this step here, right? That is absolutely fine. But this you must never skip, because
Okay,
this at
sir.
least gives us context, right? And then this you can skip, this you can skip, you can go straight to this one. It's fine. Yeah.
Okay, sir. Thank you.
Yeah. So if you wanna skip steps, make sure you are not skipping the critical ones. Yeah.
Thank you, sir. Will do.
All right. Right. What's this thing? Right. So someone had a question about some question that they
Hello.
did, but they didn't get the same answers. Yes.
No, I'm not that person. I have another question, me.
Based on
Yes,
what you just did. All right. Go.
it's page 3, sir.
Also
1.3.
page 3, 1.3. Okay. We'll go to that just
1.3.
now. So there's this gentleman that had a question.
Is that me?
What is your question?
Hello. Hi, sir. I just want us to please go through the projectiles when they're projected at an oblique angle.
Projectiles will go through. Okay, so projectiles you can go through today, but we'll look at them tomorrow.
Oh, okay.
Mm-hmm.
And also I was going to ask, right? So for the test, it's certainly going to be the kinematics and statics, right?
Under statics beams, yes.
Okay.
So it's not a whole,
And you won't,
just beams.
and you're not gonna change that, right, sir?
Why would I change it? Why would I
So,
change that? No.
some tutors, they say to you that you're gonna have a certain scope for your test, right? And
Mhm.
then when you're doing it, you see more stuff or different stuff.
No, my guy. We don't do that here.
Yeah, they edit the stuff, sir.
Oh,
I know
If
we
you
don't do
start
that.
typing and then they edit the message.
Yeah, we
that's
for
why I
my
was
stuff,
asking in
we
the
don't do that.
group, sir.
Mm-hmm.
That's why I was asking in the group because I just want it to be official so that there's no nasty surprises come test day.
There won't be any nasty surprises. For the first assessments, kinematics, under kinematics, you have relative velocity, resulting velocity, projectiles.
Mm,
And then under statics,
yes.
it's only beams.
Okay.
Yeah.
Thank you, sir.
All right.
Okay.
So you said which page? Page 3.
Yes, so page 3, number 1.1. Sorry, 1.3. 1.3, page
1.3.
3.
Okay. Okay. See if I have this one here. 1.3. 1.3. Yes. So this one.
Yes, sir.
All right. So a light aircraft with an airspeed of this. So that's the airspeed. So that's VO takes off at OR Tambo Airport in the direction south 33 west. The aircraft is blown off course by a wind blowing at 138 kilometers per hour from a direction. Okay. Calculate the resultant of the aircraft magnitude and direction. You weren't able to get both the magnitude and direction.
No, so I got way less than what they got 347,228 kilometers per hour. I got 164,466 kilometers per
So
hour.
that's important. So you can't have a VR that is less than both VO
Both.
and VW. Do you see what I'm saying?
Yes, sir.
All right, let's do it quickly. In fact, this one we will not do. We'll just draw the vector diagram. Nah.
Okay, sir.
So which method did you use here?
I use the method of components.
Method of components. Okay. Let us use the method of components then. So you have VO, which is 300 in the direction south, 33 degrees west. Right. That will be right. Now, if you look at the angle or the direction of VO, right, it's south 30 degrees, 33 degrees west, which means our angle RF is referenced from south. South is along the y-axis. So you are supposed to calculate the angle that is referenced from the x-axis here, which means VO is 300 kilometers per hour. Direction reference from the x-axis will be west. Angle is 57 degrees south. All right, so that means VO is in the third quadrant. All right, so VO is what the hell? All right,
So
VO. Yes,
I do have all of that. It's in the third quadrant, and
yes,
then the wind that's blowing at 138 is much northwest, so it needs to be in the opposite quadrant, which means now it has to be in the southeast quadrant. Am I correct?
yes.
I have that. Like I did everything I did normally, so
Okay,
but
wait.
so I can continue
So,
and then I can see where I went wrong.
okay, I just want to find out from you. which angle you used here. So this will be 5-7. Yeah, that will
Yes,
be
57.
5-7.
And I must say the 90 degrees minus the 33 degrees, and then I got 57 degrees.
Okay, so this will be right there. So just tell me if you have the same components. This will be VO in the y direction, headed south, so negative 300
Negative 300 cos 57.
sine 57.
Is it- Oh, yes, sine
Y
57.
component.
That's the y component, yes. And then
Yes,
the x component is minus 300 cos 57
minus 300 cos
degrees.
57. Okay, so you got that right. And then you have this one, which is say round about there. Right, this angle is, do you have 41 degrees there?
Where?
Do you have 41 degrees for this angle? This is
40,
for VW now.
VW, I have 49 degrees.
So that is where you went wrong. If you look at 49, it is reference. If you look at 49, it is reference from
Yes, sir.
north. North is along the y-axis.
Yes, sir.
The angle that you are going to use must be reference from the x-axis, right? So instead of
Okay.
north 49 west, you would use west 41 north. That's
So
the
it's
angle that
90
we
minus
selected.
49.
Yes,
Oh, so I didn't do that. I didn't
yes,
subtract the 90 degrees
49.
from the 49. Yes,
Yes,
that's my mistake.
yeah. So that was the mistake.
Okay. Okay, thank you, sir.
Can you repeat that again? Can you please repeat that again?
So when using the method of components, right, it is better that you use or that you reference your angles from the x-axis, right? So just like how we did with VO, the direction of VO is south 33 degrees west, right? And remember when I explained last week to you guys that
Oh,
the direction has two directions, right? The direction that comes before the angle tells us where this angle is referenced from, and the second direction or the direction that comes after the angle tells us in which quadrant we are going to land. Now, for the method of components, it is convenient that we reference our angles from the x-axis. So seeing that in this case, VO, the angle is referenced from south. South is along the y-axis, meaning that the 33 degrees is referenced from the y-axis. That is why we recalculated the angle so that we have an angle that is referenced from the x-axis. And you said 90 minus the 33 and got 57. Right, the x-axis are headed west, so meaning the direction reference from the x-axis will be west, the 57 degrees south. Right, similarly with the what is this? Similarly with this thing, with the wind direction. Now the wind direction is given in a or is given from the perspective of where it is coming from. So meaning that if it is coming from north 49 west, it means it is going in a direction or it is headed in a direction opposite this one, which is uh, opposite of north, south, 49, opposite of east. I mean, opposite of west is east, right? So meaning our what is this? Our wind is headed in this direction. It is coming from this direction, meaning that it is headed to this direction. But then again, the 49 degrees, it is reference from south. South is along y-axis, meaning that we need to work out the angle reference from the y-axis. So you say 90 minus the 49, which is 41 degrees, right? Not west. Where's this west coming from? And this. Okay, so this is supposed to be east 41 degrees south. Are we together now?
yes, sir.
The other
I
gentleman.
think also,
Yes,
sir,
sir. Yes, sir.
Yes. You were saying?
the reason why I think why I also got it wrong is because by the previous activity, I changed from southwest to northeast. So my X reference made sense to not subtract it to not subtract the 90 from the degrees
From the
given.
given. Yeah.
Where, whereas in this activity, it's now from the northwest going over to the southeast. So
Yeah.
now changed. It's now the opposite side.
Yes.
So now my axis is also changing. So
Yes.
now I didn't apply thinking that it's still the same process. I didn't apply the same method
Yes.
as you explained to us that you must reference it from the x-axis
Yes.
always.
Yeah. It's just convenient that way. That way, you know your x components will be in terms of cos and your y components will be in terms of sine. Instead of having other components, like instead of having one x component in terms of cos and the other x component in terms of sine, it makes it convenient if all the angles are referenced from the x-axis, so that your x components are in terms of cos and your y components are in terms of sine. Just makes it easier that way. Nah?
Yes, sir.
Right. And then, of course, from here, you then apply conditions of equilibrium.
Thank you, sir.
Nah. Any more questions?
Yes, sir. From me again.
Okay.
All right. So I hope this makes sense. So I do the method of components using an angle all the way from your horizontal line from east all the way around to your wind direction as example. So my when I do my horizontal component, I have 300 cos 237 because it's 1990 plus 57 gives you 237. Then it's 1990 plus whatever's left give you 309 for the next um, cos or sine angle. Am I correct by using this method? I get the same answers though.
Yeah, it's correct. It
Lovely.
is.
Thank you.
It's mathematically correct. I don't teach it
Yeah,
though. I
yeah, just
prefer.
makes more sense to me though.
Okay. No, that's fine.
Cool.
That's
Thank you.
absolutely fine. Any more questions? Right. Now, tonight, try these activities. Right. On page 4, try the first 1.3. Right. So I want you guys to try this activity. Right. So page 4, try that 1.3. Right. And then try this 1.3 and try this 2.1.
Okay.
Nah, try these
Okay,
ones.
sir.
We'll look at them first thing tomorrow during our session.
Okay.
So it's
The guys.
1.3, sir. 1.3, 2.1.
Yeah,
So it's
you can take a
1.3,
screenshot.
1.3, 2.1.
Okay.
Let's try those, and then we'll discuss tomorrow. I'll also
Okay,
send
sir.
you. I'll also send you some notes on what is this? Oh yeah, we are. So is everyone on Moodle now?
Yes, sir.
All right. So I'll upload some notes on projectiles.
Okay, sir.
All right.
Quick question, sir.
Yes.
Are we gonna do beams at some other point? I think yeah, we have class tomorrow.
Yeah, we have class
So
tomorrow. So tomorrow we'll look at um, projectiles. We'll do maybe one or two examples. In fact, I think there is a video. I'll first have to confirm if there is a video
Sir, you
that
have
I set
yes, you
up.
have the video. I've watched the video already.
Okay, so you'd have to
I've
watch.
I've watched I've watched a video of projectile on YouTube with the previous
Okay,
the video
okay,
for last year.
Okay,
Yeah.
so there
I
is a
watched that
video.
one.
So
Yeah.
go to Moodle. There should be a video uploaded under projectiles. Watch that video. Once you are done doing the 3 activities. So once you are done doing these 3, right, just watch the video before class tomorrow. Doesn't have to be
So
tonight.
so the same video that is on Moodle is the same video that is you have on your YouTube channel.
I believe so.
Okay, sir. Because I watched that one. The
Was
one
it
on
my
YouTube.
video, right? Is it my video?
It's a live session like this, but
Oh
it's
yes, yes.
on.
Yeah. Then yes, it's that video.
Okay.
Sorry,
So just
sir.
make sure you have watched the video before our session tomorrow.
Okay.
Okay. Sorry, sir. Just for my clarification, there's a video for Beams as well. Apologies, I
Yes.
haven't been on Moodle,
Yes,
so
there
I'll
is.
just.
Yes, there is.
All right. Lovely.
Yeah,
I'll
there
check it
is.
out. Thank you, guys.
Okay.
And
Sure.
then, so after our session tomorrow, you can then watch the video on Beams, and then maybe we can have a session, probably Saturday, to address questions on Beams.
Okay. So when you say beams, are you only gonna are you including the bending moments and the shear force diagram also?
Yes,
Okay.
but we'll discuss on Saturday. If
Okay, no problem.
to see if you guys have grasped the concepts around shear force and bending moment diagrams.
Okay, so I'm done already, so I'll just catch up with you.
All right. Is that fine with everyone for us to have a session on Saturday?
What
That's
time?
fine with me, as long as it's in the afternoon, though.
Yeah, in the afternoon is fine. Say
We have
around.
So,
Yes.
Mechano technique, so we know we're gonna have a lesson with that subject.
Meccano, Thursday. I'll communicate. in the
Thursday.
group.
Okay,
Thursday.
sir.
Yes.
Okay.
Are we done?
If there are no more questions, then yes, we are done.
Okay.
I love the initiative, guys. Keep it up.
Okay, sir.
Thank you,
Thank you.
sir. Thank you for your efforts.
You.
All right. Cheers.
Cheers.